Hey guys, so here's a question on electrical circuits. Let's have a look at the question. An ammeter is a device that can be arranged in a circuit to measure the current flowing through a particular part of the circuit. Now, which of the following sets of characteristics should it possess? So the options are different variations of the same answer. So the ammeter should ideally have a high resistance and be in series with the part or the device whose current is measured. Low resistance in series, high resistance in parallel, low resistance in parallel, or it should have the same resistance as the device being measured and should be arranged in series with the part being measured. Now let's take an example circuit. Let's take a energy source or a voltage source, which is a battery. Let's take an electrical component such as a resistor, whose current I need to measure. So in this simple electrical device, these are the terminals of the battery, and this is the direction of conventional flow of current that we assume. Now, we know this, that in an electrical device or in any electrical circuit in general, the current flowing through two components is same in series and splits in parallel, while the voltage across two components in parallel remains the same and splits in series. So if I need to measure the current I across this resistor R, I need to make sure to connect my electrical component, which is the ammeter, in series with the device. This is how I would connect my ammeter. So we know that the answer is it has to be arranged in series. That still leaves us with two possible options, either A or B. Now, an ammeter is a device that measures the current. Originally, if the ammeter were not present, current I would be measured as V by R. With the inclusion of the ammeter, the overall resistance will certainly increase because an ammeter is in series, sorry. So the overall resistance R effective will be the original resistance R plus the resistance of the ammeter, giving my new value of current I as V divided by R effective, which is R plus RA. Now, the value of current I should not change just because I introduce an ammeter in the circuit. For this to happen, the resistance RA of the ammeter must be as minimum as possible so as to not affect the value of current that it is measuring in the circuit. So when I say as little as possible, I mean a low resistance. So because of these underlying factors, we know that an ammeter is a device which has a very low resistance and is in series to the electrical component whose current needs to be measured, whereas a voltmeter is the exact opposite. It's a device with very high resistance so that it does not draw any current. IV is equal to 0. And it is parallel so that it measures the accurate voltage across the terminals of the resistor. So the answer to this question is option B. Thank you.